Hello everyone, welcome back to coinslive. In this video, we are going to solve LeetCode problem number 973, k closest points to origin. This is a medium level problem, but the core idea is quite simple. Once we understand how to calculate and compare the distance of different points from the origin, we will first understand the problem, then develop the intuition, implement the solution in Python, perform a complete dry run, discuss the time and space complexity, and finally look at some common mistakes. Let's begin. We are given an array called points. Each elements each element inside this array represents a point on a two-dimensional plane. For example, 1, 3, and 1, 3 represents a point whose x coordinate is 1 and y coordinate is 3. We are also given an integer k. Our task is to return the k points that are closest to the origin. The origin is the point 0, 0 in this point. The answer can be returned in any order. Let's understand this using the first example. Example number 1, this is the figure and these are the points 1, 3 and minus 2, 2. And here k is equal to 1. We need to find the point that is closest to the origin. The distance of 1, 3 from the origin is square root of 1 square plus 3 square. This will be the distance from the origin of 1 3 point, and it will become square root of 10 because 3 square is 9 and 1 square is 1. 9 plus 1 is 10. The distance of minus 2 2 from the origin will be negative square plus positive square, that is 2 square plus 2 square, it will be 4 plus 4, that is 8, and square root of 8. So this distance will be square root of 10, and distance of minus 2 2 from origin will be square root of 8. So we can see that the square root of 8 value is smaller than square root of 10 value. So the nearest value, the nearest point to the origin will be minus 2 2. Therefore the answer will be minus 2 2. Now understand the distance formula. Why I written the formula like this? Just square root of 1 square plus 3 square. There is more in the formula to understand. The Euclidean distance between two points is calculated using the formula under root of x1 minus x2 square plus y1 minus y2 square. Since we are calculating the distance from the origin has the coordinates 0, 0. Therefore, for a point x, y, its distance from the origin is square root of x square plus y square. Let's understand it more deeply. The formula is, you can see that x1 minus x2. Suppose we are finding the distance from x, y point to origin. It will be here x1 is x, y1 is y, x2 is 0, y2 is 0. So we will put the formula here. It will be square root of x1 minus x2 is x minus 0, right? X minus 0 is x and x square. It will be x square plus y minus y2. So y1 is y and y2 is 0. So y minus 0 is y. So y square. So this will be our formula. That's and the same thing I written here. So to find the distance from a point to origin, we will just follow this formula, square root of x square plus y square. For example, for the point 3 comma 4, right, it will become square root of 3 square plus 4 square, and 3 square is 9 and 4 square is 16. So 9 plus 16 is 25, so it will be square root of 25, which is equal to 5. However, there is an important observation. We don't actually need to calculate the square root. Suppose one point has a square distance of 8, okay, and another point has a square distance of 10. We already know that square root of 8 is smaller than square root of 10. Therefore, uh, comparing the square distances gives us the same ordering as comparing the actual distances, right? So instead of calculating square root of x square plus y square, we just simply calculate x square plus y square. And this makes the implementation simpler and avoids unnecessary square root calculations. Now the simplest solution will be first calculate the square distance of every point from the origin. Then sort all the points based on their squared distances. After sorting, the closest point will appear first, the second closest point will appear second, and so on. Finally, we will return the first k points. For example, suppose we have 3 comma 3, 5 minus 1 and minus 2 comma 4. These 2 points are, and k is equal to 2. The square distance of 3 comma 3 will be 3 square plus 3 square. It will be 9 plus 9, which is square root of 18. We will just remember 18. And the another point 5 comma minus 1, the distance will be 5 square plus minus 1 square. So minus 1 square is 1 and 5 square is 25. So 25 plus 1, that is 26. And the third point is minus 2 and 4. Minus 2 square will be 4 and 4 square will be 16. So 16 plus 4, 20. So the points arranged according to their distances are 18, 20, 26. We need the closest 2 points. So we will return 3 comma 3 and minus 2 comma 4 because 18 and 20 are the smallest. That is the complete idea behind the sorting based solution. Let's write the code. This function receives two inputs. The first input is points array and the second input is k, which tells us how many closest points we need to return. The function returns a list of points. Now look at this line. We are sorting the list called points. The key parameter tells Python what value should be used to compare the points. For each point, the lambda function calculates this. Here, zeroth index of point represents the x coordinate and first index of point uh, represents the y coordinate. So we are squaring it using the double asterisk exponentiation. The final value is the square distance of that point from the origin. Python sorts the points in increasing order of this value. After sorting, we will return our answer. This is Python's list slicing. It returns the element starting from index 0 and ending from index k. Therefore, it returns the first k points. Since the list has already been sorted according to the distance, these are the k closest points. Now, let's dry run example 1. Initially, the points are 1, 3, minus 2, 2. The first point is 1, 3. The square distance is 1 square plus 3 square, that is uh, 9 plus 1, 10. And the second point, minus 2, 2, the value will be minus 2 square plus 2 square, and it will be 4 plus 4, that is 8. Sorry, 8. Python Python compares the distance. Since 8 is smaller than 10, the sorted array becomes minus 2, 2, this. This will be the result after sorting. Now we will return the first k points, that is k is equal to 1, so we will return minus 2, 2. This matches the expected answer. Now let's dry run our example 2. Let's calculate the square distance of each point. 3, 3. 3 square plus 3 square is 9 plus 9, that is 18. The value of 5 square plus minus 1 square will be 26. We have already calculated these. And minus 2 square plus 4 square, that will be 16 plus 4, 20. First comes 3, 3, whose square distance is 18. Then comes minus 2, 4, whose square distance is 20. And finally comes 5, minus 1, whose square distance is 26. The sorted list becomes this. Therefore, we will return as k is equal to 2, so we will return 2 points, 3, 3 and minus 2, 4. The problem allows us to return the answer in any order, so the following would be also accepted. If we put minus 2, 4 in the first zeroed index and 3, 3 at first index, that will that can also be the answer. So both can be our answer. Let's run this solution once. Okay, the solution is accepted. Now let's deeply understand that why we do not need the square root, why we didn't calculated the square root of the distances, right? Um, let's understand this important point that suppose the square distances of 2 points are 18 and 20. The actual distances are square root of 18 and square root of 20. Since 18 is smaller than 20, the square root of 18 will also be smaller than the square root of 20. The square root function preserves the ordering of positive numbers. Therefore, calculating the square root does not help us make a better comparison. It only adds an unnecessary operation. Let's discuss the time complexity. If n be the total number of points, we sort all n points. Sorting will take big of n log n time, and returning the first k points takes approximately big of k time. Therefore, the overall time complexity is n log n, because sorting is the dominant operation. The space complexity depends on the internal implementation of Python's sorting algorithm. The auxiliary space complexity can be considered big O of n, and the result list containing the first k points also requires big O of k space. For more interview explanation, we can say time complexity n log n and space complexity big O of n. Now, can we solve it using a heap? We could place points inside a min heap according to their squared distances and remove the closest points k times. We could also maintain a max heap containing only k points. That approach can reduce the time complexity to big O of n log k, which can be useful when k is much smaller than n. However, Python does not directly provide a max heap, so we would store negative distances. The heap solution is more optimized for certain cases, but the sorting solution is easier to understand and is fully accepted under the given constraints. Since the number of points is most 10,000, as big of n log n sorting solution works comfortably. Now let's discuss the common mistakes that we can make. Mistake 1 is calculating only one coordinate. Some learners may sort the points using only x coordinate or only y coordinate. For example, only y square or x square. This is incorrect. A point's distance from the origin depends on both x coordinate and y coordinate. We must use x square plus y square. The second mistake is forgetting to square negative values. Suppose the point is minus 2 comma 4. So minus 2 square is 4, and we have to calculate the distance using minus 2 square plus 4 square, which is 4 plus 16, that is 20. Negative coordinates do not create negative distances because they are squared, right? The third mistake, using Manhattan distance. Some learners may calculate absolute value of x plus absolute value of y. This is called Manhattan distance. But the problem specifically asks for Euclidean distance. Therefore, we must use x square plus y square. The fourth mistake, that calculating the square root unnecessarily. We don't I already discussed that we don't need to calculate a square root. The square distance is enough for comparison. The fifth mistake that we can make, that returning only one point. The problem asks us to return the closest k points, not only the single closest point, right? Therefore, after sorting, we must return k points. Now the sixth mistake, assuming the answer must be sorted in a particular order. The problem clearly states that the answer can be returned in any order. Therefore, if two accepted solutions return the same points in different orders, both are correct. Let's quickly recap the solution. We are given several points on a two-dimensional plane. We need to return the k points that are closest to the origin. For each point xy, its square distance from the origin is x square plus y square. We don't need to calculate the square root because comparing square distances gives us the same ordering. We sort all the points based on their squared distances, then we return first k points. This is the code. The time complexity is n log n, the space complexity is big O of n. A heap based approach can solve the problem in n log k time, but sorting solution is simplest approach for beginners. That completes our solution for LeetCode problem number 973, k closest points to origin. If you found this explanation helpful, like this video, share it with someone learning data structures and algorithms, and subscribe to coinslive for more beginner friendly coding tutorials. Keep practicing, keep building your intuition, and I will see you in the next video. Thank you.